Hey folks, I was planning to make a video on the database statement caching, but before making that video, I realized that we haven't discussed the join type. So let's suppose you have a SQL query, you run that SQL query, send the prepare statement to the parser, so it is inside the database. Okay, send the statement to the parser parse that query, validate that query, and prepare a parse tree or a query tree, and it sends to the optimizer. Then optimizer do certain operation like index selection, join type, join order. Index selection is easy, like you have to select the best index that works for the query. There can be multiple indexes you can form on a table. So you will optimizer will select the best index. But join type is something which I never discuss on this channel. So I thought let's prepare a video on the join type. What are the join types that are available? So we will see all of these and the benchmark them. So let's see, means let's prepare the setup first, then we will go ahead. So I have written some queries. So let me write those queries to run the Postgres container. Uh, okay, already exist. Got it. Okay, let me copy this again. Run the container. Okay, it is a go into that container. Okay, yeah, we are inside a container. Then what we will do, we will create the two tables, employees and department, and we will insert some data. Okay, data inserted. Now we will understand and we will do the benchmark together, so you will know how each join type is performing. So let's go to the nested loop joins first. So as the name suggests, nested loop joins. So how it works, let's suppose you have two tables. I have told you na, user and a company. Then let's suppose a user have 100, okay, 100 rows, and company have 1,000 rows. So it just a nested loop. It this loop join will choose the smallest table and keep it at a outer layer, and the largest table on the inner layer, and just run the loop. That's it. If you see, like, it is efficient for the small tables where the indexes are used. And also one more thing, the question is for you. I told you that it chooses the small table, like in case user, okay, it chooses small table for the outer loop. So why it chooses? So that is one question for you to think about it. If you not able to think, just comment it down. I will either make a video or answer it in the comment itself. So this is the nested loop joins. Okay, this is quite simple and easy, straightforward, like a bubble sort we used to do. So let me run the query for this nested loop joins. uh, so we have the full setup. If you see, we have this Postgres, and let me first turn off the hash join, merge join, or I can run it wholly. uh, yeah, so it is just a analyze query where I'm getting the ID, name, and the department name. Okay, so E is the employee, D is the department, or I am making the key for search is the ID. Here is the department ID, here is the employee ID. Okay, I'm just running this query. So if you see this, the total time it takes, which is more important for you at this time, it's 950 ms. Okay, I'm going to copy it so we can compare it later. You can see that there are multiple operations. It does the sequential scan on the employees table. It does some operation memoization, index scan on the department key. Okay, and it tells you every information. Let me write it somewhere. No, we want this thing only. Okay, so this is the nested loop joins, how it works. The second loop join is merge join. I hope you have means you have seen the merge sort anywhere in your life. So it is similar to the merge sort. What it happens, it will sort the rows. Let's suppose you have given the rows, okay, you have given the two rows, let's suppose user and a department, and it will sort both the rows on the basis of the key, whichever key you want. Let's suppose ID is here, so it will sort on the basis of the ID. Then it will merge them, okay, them, and return it to the output. So the time complexity of the previous, the nested loop join is O N M. N is the size of the user, M is the size of the company. So O N into M. Okay. But join type merge joins, its time complexity is O N plus M when the columns are sorted on which we are applying the merge, or we are applying the joins. Okay. Um. So this is means merge join. Let's understand better. Joining to data set based on the sorted key. I already told you. Uh, okay. Efficient for the small table when indexes are used. Okay. When the indexes are used, they are already sorted. Indexes are sorted by default. Okay. So that's why it is saying for small table, or when the indexes are used, it is better. It performs better. For outer loop, it will always choose the small table. It is on you to think about it. Why it is choosing small tables? So these joins are choosing small tables. Why? When you should you choose the merge join? So the first I already told you the complexity is O N M O N plus M, but it is when you have the sorted keys. If you don't have the sorted keys, then logarithm time you should add. So it may be O n log n or m log m. So it depends. Okay. So that is one thing. Means if the tables are not sorted, they are big, then sorting itself will take much more time. So you should be aware of these things. Uh, yeah. So when the join requires large datasets exceeds the memory. So what happened? Let's suppose in the above case, I told you like it is always take the smaller table on the uh, smaller table for the outer loop, because it needs to take the all the elements of the user rows as the IDs on which we are doing the join into the memory. So if your memory is not enough when you are doing the join and you chooses the nested loop joins, it doesn't work. Okay, so that's why it is saying when means most of the joins require the memory. Okay, but merge join work with the less memory also, because it doesn't require to get the data in a batch. Let's suppose 100 users, it doesn't require to get the 100 users, all 100 users. Okay, it just need to get around, like it is in a stream fashion. It can also get, let's suppose 10 rows of the user, 10 rows of the department. It can do the operation, then set the result, then go ahead with the next 10 rows. So this is how it can work. When the merge join is not ideal, obviously like unsorted array, high cardinality is, it is a high cardinality, then it is a duplicate. Let's it is a duplicate like comparison, so it doesn't means work that well. So this is what merge join is. Let's do the again same thing. We are again, it is for the nested loop. Let me quit it and go ahead with the, yeah, merge join. Yeah, so let's see. Merge join is taking 921 ms. Okay, so it is telling everything, means how it is taking this much time, like how many rows it is executing, like indexes, scan, departments. There are 5 rows, there are one loop, everything is there, but all we care about now is execution time. Okay, the execution time for this join type is 921 ms. Okay, how much time it will take? 950. Like, see, it is taking more time, it is taking less time, but yeah, with time, like it depends on the data. So I'm not saying it is always efficient, but you should know the data before applying these joins. The last join that we are going to see is the hash type join. Okay, it is quite like very much familiar. by the name hash joins. What it does, it takes the one row, you have table user in database, it takes the user table, and on the ID column it creates the hash. It creates multiple buckets. Let's suppose it can be possible like from 1,000 rows, it creates around like 100, or let's suppose 900 buckets, and those buckets the values are there. So what it does, like on the second table, department table, you will go get the key and say, hey, this key is available on a asset or not. So this is how it works actually. Okay, let me erase this actually. uh, yeah, so this is how it works. Okay, uh, when it is required, so let's assume a scenario when there is no indexes are available. Okay, indexes are not available, then merge join is not efficient. I already told you, due to the, like, it needs sorting of the keys on which you are applying the join. So that's why has both of the joins, the above joins will not work efficiently. So in that case, you will call hash join sufficient memory, because I told you it is creating a hash set of the one table row on which you are applying the join. So it requires the memory to create that, like, to store that hashes. It store the hashes in the memory while until the query is executed. So this is how it works. So that's why sufficient memory needs to be allocated if we are going to choose the hash join. So let's execute the query for the hash join also. Yeah. Fine. So it is taking very less time. See, 621 ms only. It is around 30% less to the other two, and it is creating the buckets, not the memory and everything. I already told you now. It is created 2048 bucket batches 170 KB memory. It takes. Uh, the first join in a loop join doesn't take any memory. So this is how it works. Its execution time is this one. So let me copy it. So you can see, like, I have explained all the three joins that are means that are important for you. In the next video, I can go ahead and teach other or discuss other lectures and lessons like optimizer, how other things works. Because this is the one of the topic that I think I should touch upon, because many of the people are not aware of this, because it is internal to database. So let's meet in the next video, where we will discuss the caching, we will database statement caching, and we will see how caching works, how we can get the benefit of the caching. Until then, bye bye, keep subscribe, bye guys.